As I was saying, the real number system is split up into the rational number and irrational number sets. Irrational numbers are numbers like the square root of 58. This is a non-perfect square. So the square root means I need two numbers that multiply to be 58. So I think about my whole numbers. 4 times 4 is 16. 5 times 5, 25. 7 times 7 is 49. 8 times 8 is 64. 58 would be in the middle of 7 times 7, 49, and 8 times 8, 64. So that means that there aren't two whole numbers that would multiply to be this. So a non-perfect square, I would call that an irrational number. When I look at number 38 though, 12 over negative 2, well, when I divide that, I would get negative 6. So negative 6 doesn't have a fraction or decimal part, but it is negative. So that means it's going to be an integer. But guys, if it's an integer, we're not just going to put integer because the instructions say name the set or sets. So if a number is an integer, it is also inside the rational number set. So we would put integer and rational. After you do that, there's a little review of scientific notation. So scientific notation, I want the decimal to be right here. So there's one number that is not 0 in front of it. So I would go ahead and write 2.84 times 10 to the, and then I need to know my exponent. 1, 2, 3, 4, 5. Oh, I had to move in the decimal 5 times. Since this is a big number, not a small number, my exponent's positive. And by big number, I mean greater than 1. Oh, so now here we have a number that's not greater than 1. So I want my decimal to go here, right behind the 3. So I have 3 times 10 to the 1, 2, 3, 4, 5. This would be to the negative 5th power because I started with a number that was less than 1. So if I have a big number, positive exponent, really small number, negative exponent. After you do that, you're going to solve more problems, two-step equation. So I'm going to go over 47, 48, and 49. So our goal is to get the variable alone, to find out what value it has. So the first thing I need to do to isolate my variable is get rid of any normal numbers that are on the same side of the equation. So I see how I have this negative 8. I'm going to add 8 to both sides. I get m over 3 equals negative 5. The variable is not isolated yet. It's being divided by 3. The inverse of dividing by 3 is multiplying by 3. I get m equals negative 15. Number 48 is a little bit different because the fraction, this 2, is dividing the whole thing. So whenever that happens, and it's not just dividing the variable like we saw here, I'm going to multiply by the 2 first. That makes these 2 go away. 2 times negative 3 is a negative 6 equals n minus 2. My variable isn't isolated yet. I just have to add 2 to both sides and equal negative 4. And then the last one right here, remember, this isn't something we learned in class, but parentheses mean multiply. You're going to multiply the 10 by each term that's inside the parentheses. 10 times 8 is 80. 10 times x is 10x equals negative 50. And then you have to go ahead and solve using your steps.